This is the two-way ANOVA video on indicator variables. Just like the one-way ANOVA, if you dive deeply enough into the guts of statistical software, you'll find that the two-way ANOVA is implemented using indicator variables. In fact, the first step is to create, for each predictor, the same set of indicator variables that you create for a one-way ANOVA. This slide is copied from the one-way ANOVA videos and is intended to remind you how the process works for a three-category predictor. Once the indicator variables are created, the categorical variable representing study group is mapped into a set of values for the indicator variables. Here are all zeros and ones. These then give meaning to the regression coefficients. Here, beta 0 represents the mean for group C, the reference group. Beta 1 represents the difference between the means of groups A and C. Beta 2 represents the difference between the means of groups B and C. This slide provides the count of the required number of basic indicator variables. In addition to these basic indicator variables, we have an indicator variable that represents the intercept, denoted by x0 and set equal to 1 for everyone. Interaction terms will require additional indicator variables. The indicator variables for the interaction terms are formed by multiplying the basic indicator variables together. Since the basic indicator variables contain zeros and ones, so will the interaction terms. This is how things would work for a two-way ANOVA, with the first factor having three levels, A, B, and C, and the second factor having two levels, D and E. The spacing is intended to highlight the difference between the indicator variables for the intercept, the indicator variables for the factors, and the indicator variables for the interaction terms. These are the values of the indicator variables for each of the 6 cells produced by the 3x2 array. Please note that the two interaction terms really are a product for the basic indicator variables. This is the result of plugging in the zeros and ones into the regression equation. For example, in a direct analogy with one-way ANOVA, beta 0 is the group mean for the reference cell. Here the cell with factor 1 of C and factor 2 of E. This is how the beta coefficients are interpreted. Together, beta 4 and beta 5 create the interaction term. You can easily convince yourself that every model with an interaction term must include the terms for its corresponding main effects. The next slide illustrates what goes wrong if you don't. You've accidentally assumed that 4 of the groups have the same mean. That's not good. To fit a main effects model, the indicator variables are the same, except for the interaction terms, which are dropped. The process of mapping the study groups to the regression coefficients works as before. In the absence of interaction, we've assumed that the impact of factor 1 is the same for all of the levels of factor 2. One thing that this implies is that the estimates of beta 0 through beta 3 from the main effects model will likely be different from the estimates of those same parameters from the model that contains interactions. This is the meaning of the parameters.